Hello. This video will demonstrate how to find the limits of functions that are different than the ones we've been looking at, and that right now we don't have the tools to do algebraically. All right? So let's look at number 39 through 48. We're not going to look at them all. It says use graphical or numerical evidence. And so what that basically means, let's say for instance this one here, as x approaches infinity. Numerical evidence, okay, choose a really big number here and see what happens. All right? As x approaches 0 from the right, choose a really small number to the right of 0, a very small positive number close to 0, and plug it in and see what happens. Remember, for number 45 and 46, it's saying just approach 0. So that means you need to come from the left and the right. Okay, very important. Don't forget about that. Okay, so these are not necessarily difficult, but they do require you to use your calculator properly and use brackets properly. So for instance, if let's say I wanted to do number 41, let's say. Okay, all right, we don't want to make the mistake of, oh, degrees 2, therefore, right? The denominator is not a polynomial, okay? So we're going to use a calculator. And don't forget, you've got to be in radians, right? Be in radians. So it says as x approaches infinity, so I'm going to use a really big number, right? So let's say 10, right? 10 to the 9th power. All right, which one am I doing? All right, number 41. All right, 10 to the 9th power, but I'm squaring that, all right? So we want to be really careful here. I've got to, this is the whole numerator, so this is my whole numerator, right? So 10 to the 9th squared minus 4 times 10 to the 9th plus 7. Close brackets, so that's my numerator. Divide by, open brackets, 2 times 10 to the 9th squared plus 10 to the 9th times cosine of 10 to the 9th. Close brackets for my denominator. And when I do that, I get 0.4999, which you can make the conjecture that the limit of this function as x approaches infinity is positive 1/2. Okay, you get the idea. Okay? Here's another question in your book that uses a function to determine the size of the pupil in your eye of a certain animal, maybe not your eye, but of a certain animal, in millimeters, where x is the intensity of the light. Okay, no problem. So when it says what happens when the size of the pupil with no light, I want you to think about that. If x represents intensity of light, no light would be, okay, find the limit as x approaches 0. Find the size of the pupil with an infinite amount of light. Okay, find the limit of this as x approaches infinity. Okay? So, for no light, let's think about this. What we would like to do is find the limit of this. Sorry, that's 0.3 plus 60. Divide by 2 times x to the negative 0.3 plus 5. Now, I have a feeling, and again, I'm coming from the positive direction, right? I can't have negative intensity. Some of you may be saying, hey, wait a minute. The degrees are the same, so I just look at 80 divided by 2. Remember, we can only do that when the numerator and denominator are polynomials. This is not a polynomial, right? Polynomial, the degree is an integer and it's positive. Okay, so we have to do something else here. Well, one thing we can do is use our calculator. All right? So what I could do, I could say, what's 80 times, again, let's get a really small number. 10 raised to the, let's put that in brackets, 10 raised to the negative ninth power, and that's being raised to the negative 0.3 power, okay, plus 60. That's my numerator, close brackets, divide by, open brackets, 2 times, same thing, 10 raised to the negative ninth, raised to the negative 0.3 plus 5, close brackets. And I get something like 39.86. All right. That's close to what we want. All right, you might say that's close to 40, and that's a good guess. All right, we're going to look at this algebraically, and you're not going to like it, but we're going to do it anyway. Uh-oh, what just happened? Did I just, what just happened? Hold on a minute, please. All right, all is better. So let's look at this a little differently and algebraically. And again, like I said, it's all a puzzle. So if I multiply this by x to the negative, x to the positive all right, okay, all right, we can, again, I'm going to just do this once for you, right? 80 times x times this times x to the 0.3 plus 60 times x to the 0.3 power. All right. Remember, bases are the same. Add the exponents. I can see that when I add these exponents, I'll just get 0. X to the 0 is 1. So in the numerator, hoping you can see, is just simply going to be that. In the denominator, same idea. We're going to get 2 plus 5 to the x 5 times x raised to the 0.3 power. Okay, no problem. Why does that help us? Okay, well, as x approaches 0, this limit will be 0. This limit will be 0. Yes, and so I'll just be left with 80 divided by 2, or 40, and again we're dealing with millimeters here. So when there's no light, the pupil will have a size of 40 millimeters. Okay? And so when we look at the limit of the function as this approaches infinity, all right, I chose a really big number here, 10 to the 10th, and I get 12. All right, so, sorry about that. All right, the limit of f of x, I'm not going to write all that out, as x approaches infinity is 12. And so I'm hoping you're seeing a nice little pattern here. As we approach 0, we're just going to look at the coefficients here. 80 divided by 2 is 40. As we approach infinity, looks like I'm just looking at the quotient here. 60 divided by 5 is 12. All right. Again, it'd be nice if you can do the algebra. If not, use your calculator and choose numbers close to 0 from the right and big numbers, and you'll see that fairly easily. So let's look at this one. I really like this problem. It says, okay, suppose I want the function to, I need to know what the function is so that the limit as we approach 0 is 8, 0 from the right, and as we approach infinity, it's 2. So let's go back here. Remember, as I approach 0 from the right, it looks like I look at the coefficients of our variables. If I want to find to infinity, I look at these coefficients. Hope that makes sense. So if I want to look at this. And we had x what? X to the negative third power. All right. And we want this limit to be 8. Okay, pick some numbers that make 8. I don't know, 24 and 3. All right, and as we go to infinity, I want the limit to be 2. I don't know, 6 and 3. All right. So this is a kind of a nice problem in helping us, just to be a little problem solver, to be good problem solvers. All right. Let's go back to this one more time. I hope this makes sense to you. Right? When there's very little light out, your eyes, your pupil needs to get really big to get as much light as is available. When there's an infinite amount of light, when there's tons of light, your pupils are going to contract because it can't take all of that light. So it doesn't need to be so big. I hope that makes sense. More light, pupils get smaller. Less light, pupils get larger. Okay? Well, that was a little mishmash of a variety of topics. Again, the big thing here is if you can do the algebra, great. If not, you always have the backup of choosing values of x close to what you are approaching for the limit. All right? Just take your time, use your brackets properly. Remember, if you are dealing with a trig, always be in radian mode and so on. All right. Well, I hope that helps. Thanks for watching.